In the previous video, we saw that the TCP listener bind associated function doesn't return a new TCP listener, but it actually wraps the TCP listener in a result enum. So the result enum is in the core of the error handling in Rust. Errors are a fact of life, and where Rust differs from other languages is in that it requires you to acknowledge the possibility of an error and take some action before your code will compile successfully. This requirement makes your program more robust by ensuring that you will handle errors appropriately. Rust groups up errors in two categories: recoverable and unrecoverable errors. An example for a recoverable error is a file not found error. In most cases, you would not want your program to crash if you try to read a file that does not exist. So this is a recoverable error that can be handled. Unrecoverable errors are generally a symptom of a bug. For example, trying to access an index beyond the end of an array. Most languages don't distinguish between these two kinds of errors and handle both in the same way using exceptions. Rust does not support exceptions. Instead, it has the result enum for handling recoverable errors. Here is the definition of result in the standard library. We see that it is similar to the option enum that we have already discussed, but it is used to express the result of an operation that might fail. It can be in one of two states. It can be OK, wrapping the result of the function. For example, in our TCP listener bind, if the result is OK, it will be wrapping the actual TCP listener that we want to get from this function call. Or it can be in the error state, where it will wrap some kind of an error. This error here can be anything from a simple string containing an error message to a more complicated struct with extra functionality. So these are the two possible states, and we see that it is generic over these two types. So the first type that we specify is what we might get if the result was successful, and the second type is what we would get if the result was an error. Like the option, the result enum is included in every Rust file because it is so widely used, so we don't need to manually pull it into the scope. Now let's look at the bind function that we have here. Because binding to a new socket might fail if, for example, the address is already in use, the bind function returns a result. And if we actually click through, we can see the implementation of the function, and we can see that it returns a special kind of result, which is in the IO module. So this is not the generic result that we just looked at. If we click through to that, we see that it is just a special type that wraps the general result. Using this syntax in Rust, we can define custom types for our program. In this case, this is the IO result type that equals the normal result, but it will always yield this error struct defined here. So pretty much an IO result is a regular result, but the error type that it might return will always be this struct. And the first type is whatever we specify. For example, in the bind function, it is specified that if it's successful, it will return a new TCP listener. Let's go back to our code. As we said, this is a recoverable error because the bind function will just return a result and we decide how to handle it. Generally, we might not want to terminate our program if we fail to bind to a socket. But in our concrete case, if we fail to bind the socket, there is nothing else that we can do with our server. If, for example, there's another process that is already using this address, our server cannot continue to run. So we actually want to convert this recoverable error into an unrecoverable error. We do want to terminate our program if this fails. To do that, the result enum has a nice function called unwrap. If we call unwrap on a result, it will look at the result value, and if the result is OK, it will actually return the value that the OK is wrapping. So in this case, when we call unwrap, it will return the TCP listener. But if the result was an error, it will terminate our program and it will log the error to the screen. So let's actually look at this in action. If we come here, first let's make sure that our code compiles. Yes, everything compiles fine. Now if we try to run it, yeah, we see that we still get our log line and the process exits. That means that we successfully did bind the socket. But what if the address is already in use? If we open a new terminal here, we can use a program called netcat to bind a socket to the port that we're using. If we come back to the code and in the main function, we see that we're binding to localhost port 8080. So in netcat, we would also like to bind to port 8080. So we can run netcat. We're passing two parameters, -k and -l, that will just tell it to listen on this port, and we pass it a port 8080. So right now, netcat did bind to this port. If we actually resize this a bit, so because we don't want to take up a lot of space. Now, if we try to run our server again, oh, we see that it failed. We got our log line, which is what we would expect in our server, but then right after that, it actually fails because the main thread panicked, calling the unwrap on the result because the result was an error. And the contents of the error was that the address is already in use and the message is, address already in use. So now, if our server fails to bind to the socket, it will just terminate. But if we stop netcat, we can successfully run our server again. Now we are familiar with the option enum, which helps us handle no values, and the result enum, which helps us handle errors in our code. These are the two most important types in the Rust language.